Okay, so we started the last time talking about classes. What are classes? It's a way for us to kind of be able to define our own data types. Yeah, we looked at one particular example, which is the point class. So whenever you're creating a class, the first thing you think about is what are the properties of the objects from this class. So a point, what are its properties? It has an x coordinate and a y coordinate. Okay. So this is really the variable class variables. Yeah, I have an x coordinate and a y coordinate. Okay. Now, if I want to define a point, I have to pass two things, right? It's x coordinate and y coordinate, and then I can do a lot of things, like with this, one or more points. Okay, so this is what we've done. So let me show you the class code that we've written the last time. Okay, I have, right, the class is the keyword, and then I give it a name, any name you want. And as we said, for now, it inherits from object. So I have to pass, object as the parent class. Yeah, we'll see what this means in more detail, hopefully in next module. Now, the first thing, every class should have, ideally, what is called a constructor. Yeah, so this function that I'm highlighting here, the init, is a constructor. It allows me to create objects of type point. Yeah, takes usually the parameter self, which is an implicit thing. So when I call or instantiate an object of type point, self would be this guy on the left hand of the assignment. Yeah? And then it takes two parameters or arguments, x and y. And I'm saying, set self.x. So really for this point P1, right? Its x coordinate is going to be the x that I pass, and its y coordinate is going to be the y I pass. So this is how I invoke the class, or use it. I just say, okay, define a variable P1 like we did, with integers, or we did with lists, right? So I have a variable, and I want to, make it the object of type point with the x coordinate being 3 and the y coordinate being 4. Okay, good. And I created two objects here in this example, P1 and P2. Give me a second. So I created two objects, P1 and P2, right? Each has their own x and y coordinates. Now I can define any sorts of functions that I want in the class. So for instance, here I'm computing the distance between two classes, between 2 points, I'm sorry. So I have point P1 and P2. I can define a function. So this is a function that takes two parameters, a point and another point, 2 points, right? And measure the distance between them. So what is the question, Jed? So what do you mean by other.x? What is the distance between 2 points? If I give you 2 points, P1 and P2, P1 has x and y coordinates, and P2 has x and y coordinates. How do you compute the distance between them? You do square root, right? You do square root of, the difference between the x coordinates squared plus the y coordinates squared. Okay, so that's really what I'm doing here. Self.x, that's, the point that I'm going to pass, one of the points. So here I can call this function by doing this. So, you have self.x minus other.x, right? What is self? It's the P1, the one that is calling the distance function. And what is other? It's the other one that I'm passing. Yeah? So always self is implicit, you don't pass. And then I'm doing, x coordinates squared minus, plus the difference in y coordinates squared, and then taking the square root of this. Does that explain it? Okay, so far, how's the internet connection? Hear me well? If you have issues, I need you to give me feedback, because, if everything's going smoothly, I'll ask our IT, admin to leave. Okay, good. Right, Hazi? No cutting today, so far. Okay, great. Okay, so I think you can leave. You're here on campus?
Yeah.
Can you give me best your extension, and I'll call you if I need it.
37
37
387
387
023.
Why?
Also on 4000.
4000?
Yeah.
And your name is?
Mazen.
Mazen. Okay, amazing. Thank you. Yeah, let's see. Bye bye. Okay, guys. So I don't know what raycast in C#. I remember I've developed with C#. Rawat is asking me a question, right, about C#. I don't recall what is raycast. It's like object-oriented programming, classes in any language, Java, C, it's similar, very similar, right? You're creating an object. Other questions? Okay. So let's print this guy. Let's say I want to print P1, the distance of P2. And let's see what happens when I execute this code. ed. What it does, it prints, this, the distance between these 2 points. So let's see what really is happening here. Okay. So I'm calling, I'm printing one thing, P1, the distance of P2. What does this mean? This will go here, the interpreter will see P1 dot distance. Oh, I know that P1 is point. So I'm going to call the distance function defined inside the class definition, class point definition. Okay. What is self? It's P1. What is other? It's P2. And now the rest is like any other function, self.x means, the x value of P1. Other.x will be the x value of P2. I know these already. One is 3 and one is 4, and so on. Okay, we're gonna do a lot more examples on this, but just try to get the overall picture. Okay. So in general, right, this is the method, the way we've tried to do this. So here I have 2 points. I've defined 2 points. One is P and one is the origin, with their x and y coordinates. I can say P dot distance of origin or origin dot distance of P because it's symmetric. There's also the way, the other way, which is to call it using the class name. So I'm saying point dot distance, the name of the class. I call the class point with an uppercase. So point this distance as if I'm calling this function, distance, and now I have to pass 2 arguments to it, self and other, because I'm not calling it with a particular instance of type point. I'm calling it using the class. So it expects 2 parameters. Here, P would be self and origin would be, exactly, it should give me exactly the same value. Okay? Sorry. Other questions here? So let's print this object, So let's try to print, P1 and P2, so, or P1 just for the sake of, illustration. So I'm gonna print P1. Let's see what it does. What did it print? Can anybody tell me what does that mean? It tells you the following. It tells you P1 is an object of type point, and that's where it is stored in memory. So it's really not printing. I expected it to print, the x coordinate of P and the y coordinate of, of P, something more interesting with P1. But here, what it does is it prints just, the reference to the object. And so it tells you this object is of type point, and that it's stored in memory in this address. And this is in hexadecimal. Okay. So it's not really, user friendly. We wanted ideally to print something interesting, like the x coordinate and the y coordinate of the point. So this is uninformative. We can define in every class, you can define something called a special method called string. So underscore string underscore. Similar to the init, it's a special type of function. What happens is once you define this function, whatever you do in it, this method will be used when you call print. So when you call print of P, instead of printing this, it's going to go and see, do you have this method defined in your class? And if yes, it's going to use it to print the object in the way you told it to. Okay, so basically the string method must return a string. That can be used to print the object. Let's say the following. Let's say I want to print, you know, any point I should print it as follows, right? I give it this thing. I want to print it like this, you know, you know, I don't know what they call, like less than and greater than, like these enclosing brackets or symbols, and then the x coordinate comma the y coordinate. That's how I want to print. Okay, so how can I do this? Let's see. I have to go to the class definition. And define something called, you know, underscore string underscore. And what does it take? It takes self, right? Because I'm gonna call it, you know, the object, the variable I'm using for object of type point dot print of p. Yeah. So it's really like taking self as an argument. Okay. What do I want to return? This function should return a string. The string is as follows: less than plus, you know, self dot x plus comma, right, plus self dot y. I have a bit of a problem here, so we'll fix it in a second. Now self dot x and self dot y are floats, so I need to do some casting on that, so I can, you know, concatenate. I'm doing string and string. Let's run it and then we'll analyze it. So let's see when I print p1, now what it's going to do. And voila, like magic, it printed 3, 4. Right? So what did it do? As soon as I see print of p1, if there is no function like this defined, string, no function string is defined, then it's going to print, you know, the reference to the object, which is very uninformative. To override this, to make it, you know, print something that I really think is more semantically appealing or more interesting to the user, I have to define this function string. So here is how I defined it, right? It's, you know, I do this and then print, you know, put the output the x coordinate, then comma, then output the y coordinate. Okay. If I do print of p2 and run, here's what it does. It prints the 3, 4 because I'm printing p1, and then prints p2. Understood? Questions, problems, connection issues? Okay. Yeah, so I added this function, you know, string, which takes parameter self, and we print it as we've seen. Right? This function string always returns a string, remember. Okay, so let's try to, you know, summarize this. You know, how do I wrap my head around classes and types? Yeah. So I can always ask the type of, you know, of an object instance. So when I say, so that it's a convention, Robert, right? And please ask the questions. Don't ask me the questions privately, because otherwise it makes no sense. Yeah, for the people. Please ask the questions to everyone so that, you know, the whole class can follow what you're asking. So it's a convention, yeah, to tell that this is, you know, one of the functions that are reserved. So here I had two types of function: one that I created myself, and one that is going to be, you know, reserved for a particular job. You know, this one is reserved for printing. Yeah, this one is reserved for creating an object, yeah, instantiating an object. Other functions would not have this because I'm, you know, using them for specifically. I'm defining them specifically. I'm not overriding a particular function. Okay. When I do print, so I can always ask for the type of an object. So here there is a difference between printing p after I've done this underscore string function, which will print it the way I want. And when I say type of p, remember type of any object, it will give you whether it's an integer, list, or something like this. It can also, if it's a, you know, part of a class that you defined, it will give you, you know, what is this class. You can always use its instance to check. We've done this before in assignments or exercises. You can say is instance of, you know, an object. So is instance p and point would give you true. Let's test this out. So if I do print type of P1, and then print is instance of P1 point, right? How does it do? Sorry, it takes 2 arguments. Let's see what happens. First of all, right, for this one, it prints, this is the type of P1 is point, and then the second one, yes, P1 is an instance of point. Yeah, just a side. Questions? Okay. So there's a lot of other special methods. So, to carry on what Rawad was asking. So all of these methods use this underscore, right? These are special methods that have a particular meaning. Yeah. So you can do them in any class, and they're usually doing a job that is that you've already seen before. So I have the plus, the minus, the equality, the less than, the greater than, the length, the print, many others. Yeah, you can look at the documentation to kind of get what functions are out there. Like print, we can override these functions to work with your class. So you define them with double underscores before and after to tell the Python interpreter that you are overriding a particular operation or particular function. So let's see this. If I do a function in my class and I call it add, yeah, and it takes 2 things, self and other, what it's going to do is I can invoke it by just calling self plus other. So whenever I type self plus like an object P1 plus P2, it's going to go and execute whatever is in this function. Yeah, so I'm overriding the addition operation. Here I'm overriding the a minus operation. Here is the equality, and so on. Yeah. Let's see. Do an example. How can I know that 2 points are equal? What makes 2 points equal? Can somebody tell me? So I give you 2 points. What makes them equal? You don't know what makes 2 points equal? Are these 2 points, P1 and P2, same X and same Y? Exactly. Right? So these 2 points are obviously not equal. Yeah, because they have different X and Y coordinates. So let's try to do this. First of all, right, if I try to say the following, print P1 equal P2, okay? Let's see what it does. Yeah, we know that equal in Python is double equal. It says false, okay, great. Now let's change P2 to be exactly the same as P1. So both of them are 3 and 4. And let's run again. It also gave me false. Why? Because I did not override the equal operation. And now what it tries to equate, when it equates these 2 things or checks if they're equal, it checks if they are the same place in memory, the same reference in memory. Obviously, they're not. Yeah? This one is somewhere in a drawer in memory somewhere. This is another drawer in memory. So they're not referencing the same object, even though they have the same X and Y coordinates. But I can override this. So here's how I override. I define a function called equal, which takes self and other. Right? Why self and other? Because it checks 2 things. Is P1 equal to P2? And what does it return? It has to return a Boolean. This one has to return a string. Equal is equality. Checking equality returns true or false. So I have to return a. So I'm going to return the following: self.x equal other.x and self.y equal other.y. So yeah, this is gonna check, the self. What is x coordinate? Is it equal to other? Yes, great. I'll check the y. Are they equal? Yes, great. Then I return true. Otherwise, I will return false. Now let's run it and see what it does. So the same thing, right? And now it gives me true. Yeah. Why? Because now when I call this operation equal, it's gonna go and check here in my class definition. If this method defined, this equal method, special method equal is defined, yes, then you execute the code like here. So what is P1? It's gonna be self, What is P2? It's going to be other, and it's going to just check if the X coordinates and the Y coordinates are the same. Okay. Let's see if this changes. So this is 0 and 4. It should now print false. Now it prints. Okay. So this is what we have in the slide here. Okay. So if I run it on this, if I say P equal to Q, it's going to print false because P is 1, 1 and Q is 2. Okay. Now I want you to, we'll do another exercise, a complete exercise on, on classes. I want you to really start focusing. If you get this exercise, you will be able to, do the assignment without any problems. You'll be able to do object-oriented programming without any problem here in this class and in the future. So first of all, questions about what we've written so far. We're going to repeat all of this in this exercise, and I'm going to ask you to participate. So I'm going to ask you to try to think about, everything that we need to do to create this class and use it. So here's the class. We want to create fractions. So we want to create a new type, that represents fractions, numbers as fractions. What is a fraction? It has a numerator and a denominator. Yeah, so something like this: 2 over 3, or 4 over 5, and so on. Half, like this. Yeah. So two things. The properties of the object is two things: a numerator and a denominator. Yeah. Okay. And now we want to create the methods, so to interact with this, fraction. So I can create, multiple fractions or multiple, variables of type fraction, each with its own numerator and denominator. But then I want to create an interface or, methods to interact with fraction objects. So add fractions, subtract fractions, print, convert to float, invert the fraction, and even more. Okay? So we're going to build this step by step. Okay. All right, let's start this from scratch. Gonna open this folder. Okay, guys. How do I define this guy? What is the first step? Define a new data type called fraction. What is the first line of code I'm going to write? You don't know what's the first line of code you're going to write to create a class? Class fraction, exactly. Right, so I use the keyword class, not diff, right? So it's called immediately class, right? Diff is the functions, yeah, so the methods inside. Class fraction, and it inherits from object. Its parent is object. It's an object, a Python object. Yeah, that's really the first thing. Okay, great. Second thing is create a constructor. So how do I create a constructor? So that I'm able to say, f1 is equal to fraction of 3 and 4. I have to define a particular method. What is this method called? The constructor. What is it? Yes, diff underscore init underscore, and it takes two things, sorry, three things: self and x and y. Okay. Yeah. Just to make it more clear, I'm gonna make it d and n, or numerator and denominator. Yeah. So that it's just easier. What is n and what is d? Yeah. But x and y would absolutely work as well. I'm just using more clear names for the variables. Okay. What is inside? What the definition of this init? Can somebody tell me? I'm gonna use this function to create fraction objects. Yeah, we said a fraction has two parameters, a numerator and a denominator. So I need to set something in it. Any thoughts? Absolutely. Self.n is equal to n. Great. So I'm saying, you know, the denominator is going to be the thing that passes, and self.d is equal to exactly. That's it. And that's all it does. It takes, you know, two values, numerator and denominator, and makes, you know, represent the object. So it knows here that the n is the value you passed first, and the d is the value you passed second. Okay, great. So far, so good. Now I'm able to create objects of type fraction. I can just simply say the following. Right? In my main program, say fraction or f1 is equal to fraction. What does this mean? This means that f1 is 1 over 2. Yeah, I can create another fraction of 3, 4. Right? That represents half, and that represents 3 over 4. Okay, that's it. That's so far the only thing I can do. Now I'm saying the following. I want these fractions, so I want to make something with these fractions, otherwise it's useless. So I want to be able to add them and subtract them. Yeah, that's the first thing. So how do I add two fractions? So if I do the following, you know, if I try to do half plus 3 over 4, I want to write some mechanism to be able to do that. It should return also a fraction, which has the correct denominator and the correct denominator. So what is this? You know, if I do this summation, can somebody tell me the answer is what? If I add half to 3, 4? You don't know how to add two fractions? 5 over 4. Okay. So it's saying it's 2. Yeah. It's 5 over 4. Correct. Yeah, simple, you know, semantics. Just 5 over 4. So ideally, I want to write a method that I could use to say, you know, to sum two fractions, and it should give me, you know, the correct denominator and the correct denominator. So how do I do this? Let's see. Okay. So first of all, what is the method that allows me to, you know, use the plus sign? So basically, when I say I want to write a function that when I do this, right, it understands what I'm doing. It means that I have to add these two fractions. What is this method called? It's again a special method, similar to the equal. It's the add. So I'm going to do add. And it takes two parameters, self and other. So now, if I do the following, f1 plus f2, it's going to go and execute this function, right? Where self is f1 and other is f2. Yeah. So how did you compute Joseph? How did you compute this, right? This 5 over 4. Is there a mechanism for doing that? You get right. So denominator. So I'm going to use something called denominator. What is it? It's self dot d times self dot other dot d. So here is the simplest way to do it. Yeah, it's not simplified, but here is the simplest way to do it. I have here, you know, let's say n1 over d1, right? And I want to add it to n2 over d2. Okay. Yeah, so this is the first fraction. This is the second fraction. The simplest way to do it is to say, you know, the denominator of the solution will be d1 times d2. Okay. And the denominator is going to be what? n1 times d2, exactly, plus n2 times d1, exactly. If I give it to fractions like this, this is what it's trying to do. Yeah, this is how I would solve. So I'm going to write code to do this. So I'm going to say, denominator, right, that's the solution. It's just self.d times other.d. Okay. And nominator is equal to self dot n times self, not self, other dot d. Okay. So that's the first one, plus self, or no, other dot n times self dot d. Okay. So I did the numerator and the denominator. Okay. What I wanted to return, I have the values. I want to return a fraction. Yeah, a fraction is composed of two things. What is it? Composed of, the numerator and the denominator. So return at the end. This function should return a fraction, which consists of num and. So what did I do again? Right. I'm writing this function to override this addition operation. What did I do? I just mathematically, or try to understand what is adding two fractions. You have a common denominator, which is the multiplication of the two denominators, and the numerator is going to be numerator of the first times the denominator of the second, plus numerator of the second times the denominator. And now I want to create back a new fraction. How do I create a fraction? I, have to pass it two things, numerator and denominator. Let's try that. Here. Okay, so I'm gonna call, sum is equal to f1 plus f2, and I'm gonna print sum dot n, and I'm gonna print sum dot. Why? Because sum is now a fraction, so it has two things, n and the numerator and denominator. Let's try it. And here's what it printed, 10 over 8. Is 10 over 8 the same as 5 over 4? If we do numerator divided by denominator, Khaled, it's gonna return a float, right? So it's gonna divide 10 by 8 and return a float. I want it to return back a fraction. I want everything in my life here in this program to be fractions, numerator and denominator. Yeah. Of course, this is the same, but I really want to be able to capture this concept of numerator and denominator. Yeah. So that's why I returned a fraction rather than returning numerator divided by denominator. If I do this, if I have done that, what you're saying here, right, like this, then it's going to return a float, correct? Okay. Right. You see what it returns? It returns 10 as the denominator and 8 as the denominator, which is really 5 over 4. I didn't do a simplification. The float of 5 over 4, yes. Okay. Let's do the printing first before we get back to subtraction. Yeah. So printing. How do I print an object? So here, right, I have to print, the numerator alone, the denominator alone. But really, I wanted to print the following. If you say print sum, I wanted to print the following. 10 over, like this, right on the screen. 10 and then slash and then 8. So what do I need to do to be able to print a fraction in that form? Which function I have to override? It's creating an object, Rawat. So before we get into that, it's creating an object here of type fraction. Yeah, the same thing I did here. So when I say return fraction of num and denom, it's just creating a fraction, right? Passing num as the n, passing the denom as the d. Right? So it's going to return, an object that has two values, numerator and denominator. Yes, Michael and Muhammad are saying to print, I have to override the string. So I'm going to do that. Okay, so I give it self, takes only self because just I'm printing one object. Okay. What should I do inside this function? Any thoughts? I wanted to print things like this. Half, 3/4, 10/8. So numerator slash denominator. How do I make it do that? I have to return a string. So, what do I return? Any thoughts? Return. Okay. Close self dot n, right? There is nothing called num here and then, right? Remember, this takes an object of type fraction. What is the denominator of fraction? It's self dot n. Yeah, to refer to it correctly. Plus, but the logic is correct. Slash plus self dot. There's some issue though with this. What is self.n and self.d? They are integers. Can I do an integer plus a string? I need to do casting exactly in string. So I need to do casting here. I need to cast these guys into strings. All right, let's try it out. And voila, it does 10/8 as I want. If I print, here before I do the sum, print f, let's say f1, comma f2. What do you think it's going to do if I just do this? Print f1, comma f2. So what is f1? Because I didn't here how I specified the add operation is I'm doing multiplication of the denominators and then doing the denominator times the denominator of each other. Yeah. So I did not simplify. I have to simplify. Yeah. I did not simplify, so it's going to print 10/8. Yeah. If you wanted to simplify, do some. You have to do here something. For instance, use greatest common divisor to be able to simplify. There's a question on this in the assignment. Exactly. So Daniel is saying it's just they're the same, it's just not simplified. And the assignment will ask you to update this and create a simplification. Yeah? So basically it returns really a fraction that is completely simplified. All right. So here the question is here. If I do this, print f1, comma f2. What does it do? Prints half space 3/4. Exactly. Yes. Not comma, space. Yeah, because comma gives you a space. It's going to print half and 3/4, and then it's going to print the sum, which is 10/8. Okay? Excellent. Let's do the following. How do I do subtraction? How do I subtract, two fractions? So I can do, difference. I want to do the following. I want to be able to write in my program difference equal to f1 minus f2, okay? And then print this difference. First of all, how do I do it? Let's do it manually. Half minus 3/4. How do you do that? Exactly the same, right? You do common denominator, so 8, and then 4, right? Minus 6, correct? Correct me if I'm wrong. Yes, we write a new function, but I'm saying, just manually first. If I do half minus 3/4, should be like this, right? I do common denominator, that's 8. I multiply it here by 4, and I multiply here by 6, so it's minus 2/8. Right, which is 1/4. Is that correct? Minus 1/4. Yes, right? Because we have 3. This is 2/4, and this is 3/4, so you get minus 1/4. So what is the function that I need to write to be able to do subtraction? To be able to do addition, I use this underscore add underscore. What is the function that I need to write to be able to do subtraction? sub, yeah, diff underscore sub underscore. What does it take? Self and other, two things, yeah, because it really operates on two fractions. Yeah, so it has to take self and okay. How do I write it? The same as the one before, denominator equals self dot d times other dot d. Denominator is, self dot n times other dot d. The only difference here is I'm gonna do minus instead of plus. N times self dot d. Correct? And now, what do I return at the end? I want to return a fraction, not a float. How do I return? What do I return? The same as above. Return, right? Return fraction of denominator. As simple as this. Let's see. Let's run it. Right. I did something wrong. Well, who can tell me what I did wrong? So it printed 8 over minus 2 instead of minus 2 over 8. Why? Sergi. Yes, Sergi is saying here the order is not correct. I have to pass the denominator first and the denominator. Now it should work. And voila, right? It printed the sum is 10 over 8 and the difference is minus 2 over 8. Again, it needs simplification. You can write a method or update your method to do simplification. Okay. Right. What else? Two more methods and then we're done. So I want to convert to float. So what does this mean, guys? Yeah. So this is function, right? It's not overriding anything. You give me a fraction like 10 over 8. I give you back it's float representation. It's decimal representation. So what is the real number corresponding to it? Yeah. So I want to define convert, a function called convert here. There's no underscores because it's not overriding plus, equality, minus is not printing. It's just a method that I'm creating specifically for this type. What does it take? Self, right? I'm gonna say convert p.convert or f.convert. It should give me back the representation, the float representation. Anyway, how to do this? So I wanted to take a fraction, which is composed of numerator and denominator, and returns back its float representation. So when I give it 1 and 2, right, the fraction f1 should give me back 0.5. This should give me back 0.75, and so on. How? Really simple. What is the float representation of half? 0.5. How did I get half? How did I know that half is 0.5? What do I do? Any thoughts? Float. We don't even need float. Why do you need the casting of float? Yeah, but so correct, Jad, right? It's 1 over 2 for the case of half, but in general, as Muhammad is saying, I should return, right? And self.n over self.d. You give me a fraction which composed of n and d, I give you back this. And this is a division. This is float division. Yeah. Right. It's really a float division. When you give it, remember, this is an integer and this is an integer. It's going to divide them and return back a float. Let's try that. Print, right, f1.convert. This is how I call it. Doesn't take any parameters because it only takes self. Yeah? And self is going to be explicitly this f1. So really passes f1 as self, and then it will do what is the f1.n divided by f2. Right. And as you guys see, it prints here 0.5. So I called f1.convert. It just went here, divided the 1 by the 2, and give me back 0.5. Okay. Last one. How do I do reciprocal? You give me a fraction which is half. I want to give you back a fraction that is 2/1. You give me 3/4. I give you back, 4/3. How do I do this? Any thoughts? Exactly. So I'm gonna call it inverse. Again, takes only self because just one fraction I want to flip. And what it returns as what does it return? It returns a fraction, a new fraction, right? Which is composed of self dot d and self. I flipped the denominator of of the fraction that I passed to become the denominator and vice versa. Okay. Let's try it. If I say print f2 dot inverse, again doesn't take any parameter because f2 is. What would it print? Any thoughts if I do this f2 dot inverse? So it's gonna call first this function, the inverse, does this, create a new fraction, which has 4 and 3. So flipping the numerator and the denominator, and then it's gonna call the string method to print this fraction. So what does it print at the end? 4/3. Exactly. If I try it, as you guys see, 4/3. Okay, we'll stop here. You not have any issues today with the internet connection?
Professor,
Yes.
just before you go, do you have any idea when we will know what our grades are
This week.
for the exam one, the exam two? Sorry,
okay.
Today?
Not today. Sometime this week. A couple of days or something like this.
Oh, okay.
Right.
Thank you.
You're welcome. What I want you to do is the following. This exercise, I said, is part of the assignment. I want you to do it again from scratch, please, and understand exactly what every method is doing, yeah? And then there is another built on it, which kind of does this simplification of a fraction. And so you're not allowed to write, 10/8 or 2/8, yeah? 10/8 should be actually 5/4, and minus 2/8 should be -1/4. And so we add another function called simplify, which uses greatest common divisor or something. Okay. I know this is a bit foreign to you, but as you practice, you'll get the hang of it and you'll see how cool it is. It's really fun and cool. It's not difficult at all. Okay. Thank you, everyone, and we'll talk on Wednesday.
Thank you, Professor, for the session.
Yeah, goodbye.